right, Katie, for this problem, you're just trying to match the function with the graph, and the key indicator here is your scale. So since we have a little room over here, it tells you your x scale is 1 and your y scale is 1,000. And this is your window size right here. So when they have a window size like that, the first two values describe what your smallest x and your largest x are, so 0 to 6, and then your next two describe like what your y's are, so it's 0 to 6,000. So that's how you interpret what's being said there. So if we know that the x scale is 1 and the y scale is 1,000, we know that we're going on this graph to the right, it's 1,000, 2,000, 3,000. So the y-intercept here on this graph is a little bit greater than 2,000. Okay, and we see right here for the standard form of an exponential equation that our y-intercept is 4,200. So we also know that like the y-intercept is going to be less than 3,000 because of where it's at. So we know that it cannot be this graph just because of that y-intercept. And then if you look over here at this graph, 1,000, 2,000, 3,000, 4,000, 5,000. So it looks like it's just a little bit above 4,000, which tells us, based on that y-intercept, that graph would be correct. And then what is the value of the machine after 1 year? When you go into answering that, you're just going to make sure that T represents the number of years that have elapsed since the equipment was purchased. So that's 1 year after, so 4,200 times 0.8 to the power of 1. And so if you type that into a calculator, I'm just going to do it by hand here, handheld calculator. 3,360. Let's make sure that that's right. I'm not 100% confident. Yep, there we go. So it did work in that case. I didn't read the question super carefully on that, but that's the idea on this problem.